Felix Ehrenhaft was an Austrian experimental physicist whose daring experiments pushed the boundaries of what was accepted in early atomic and optical physics. Born in Vienna in 1879, he earned his PhD at the University of Vienna in 1903, studying metallic colloids, tiny particles of metal suspended in liquid, and their optical behavior. From the start, his work focused on exploring the minute and the controversial. In the early 1900s, when many scientists still debated whether atoms were real, Ehrenhaft used ultra-microscopic particles suspended in air to observe Brownian motion, tests that gave striking support to atomic theory, because air gives those tiny particles more freedom to move than in liquids. He then entered into a sharp scientific debate, measuring the electric charge carried by single particles. Unlike the carefully measured integer multiples derived by Robert Millikan, Ehrenhaft claimed to find charges smaller than a single electron, fractional or sub-electron charges. Though his results were controversial and eventually largely set aside, they illustrated a scientist unafraid to challenge orthodoxy. Ehrenhaft also explored how light interacts with particles. Effects like photophoresis, motion of particles under light, magnetophotophoresis, and other strange behaviors near the limits of detectability. As he aged, his ideas became more unorthodox. He reported seeing magnetic monopoles, magnetic currents, and even claimed that strong magnets could break apart liquids in a process he called magnetolysis. Such claims were not widely accepted, but they demonstrated his lifelong refusal to settle for conventional explanations. Forced by political changes to leave Austria in 1938, Ehrenhaft spent years abroad, then returned after World War II to his old position in Vienna. He remained devoted to experimental work until his death in 1952. While many of his later claims did not stand the test of time, his early contributions to colloids, charge measurement, and optical particle behavior remain meaningful, not just for what he proved, but for reminding us of the significance of curiosity, skepticism, and the risk-taking that underlies scientific discovery. Please feel free to share if you enjoyed this video. Subscribe to the channel Atomic Gear for more scientific content.